Okay. How'd we do? What do we think?
D was confusing.
D was confusing? That's fair. All right. All right. So if I was you guys tackling this problem, first thing I would probably do here is make a list. So what do we know? Here's particle P, and here's particle Q. And what do we know? We know X of P, we know the position function, that's natural log of T squared minus 2T plus 10. And we know that the velocity for particle Q is equal to T squared minus 8T plus 15. All right, so let's turn this off for 1 sec. All right, so just based on all the particle motion questions you've done over the last few months, you should probably be thinking, well, I'm going to need these other formulas such that I need the position for T, maybe the acceleration for Q at T. All right, so if I want the acceleration, I should take the derivative. If I want the position, I should integrate. So that would be T to the third over 3 minus 8T squared over 2. So 4T squared plus 15T. So going with that, who knows if that's going to be used or not. But I'm just getting some ideas out there. We can say the velocity. How do we take that? Stuff prime over stuff. So that would be 2T minus 2 over T squared minus 2T plus 10. I'm going to hold off on acceleration just because that would be a giant quotient rule. And hopefully we just don't need to get to a place where that's a thing. That all said, now I have a list of formulas that I can pull from as they start to ask me some questions. So let's go back to the screen share and let's check out part A. All right, when's the particle moving to the left? Well, which particle are we talking about? We are talking about particle P. So I'm in the first column. Okay, forget this problem. Just somebody tell me, what's the plan? If I ask you, is the particle moving left or right or up and down? What are we looking for?
Take the derivative and look where it's negative.
Yeah, negative or positive, right? So in this case, if it's left, we are literally looking for the interval or intervals where the first derivative is at a negative symbol. So if we take this first derivative, this is going to be 2t minus 2 over t squared minus 2t plus 10, and we are setting it equal to 0. So if we look at this, we're going to be saying, well, what values could make this 0? So clearly 1 is going to make it 0. So I'm going to be looking at 1. How about the bottom? Is there any way to set this to 0? I mean, you could say equals 0, but is there any number that we could plug in that would get this to be 0?
Would you FOIL it maybe?
Factor, you mean?
Yeah.
Yeah, so factoring, the only factors of 10 are 10 and 1 or 5 and 2. Neither of those are going to make that middle term, so it's not factorable. Even if you kind of guess and check it a little bit, if I plug in 1, whatever happens here, plus 10 is going to make it positive. So that's never going to be 0. If I plug in 2, now anything from 3 and above, that's going to be positive. So there's no real way to make the bottom 0. So if you come down here and, oh, I thought it was on this page, never mind, I lied. So if we keep that in mind, the only real thing that could make this 0 is if we just set the the top of that to 0. And so then what should we do from there, somebody?
Find the like the horizontal asymptote.
Well, we got 1, right? So what else can we do here to try to figure out? We're trying to look where it's negative now. So what would your plan be here?
Can you like plug in like 1/2 and see if it's negative?
Yeah, so we want to plug in some stuff here and see what we come up with. So if we plug in, I don't know, let's try, yeah, 1/2 seems reasonable. And if we plug in, is there any bounds on this? It goes up to 8. So anything up through 8, I don't know, let's plug in like 6 or something like that and see where that takes us. So first derivative test gets plugged into the first derivative. So what happens when we plug these in? Did anybody do them?
I did the first one. I got like from 0 to 1, it was negative.
And then from this one out, it was positive.
Yeah.
Okay. So with that all being said, does it make sense to say, I mean, that's correct, right? So the answer here is going to be, you show that work and you're going to say that the particle, now in this case, I would call it the particle P, is moving left on the interval. What are we going with here? It's going to be on the interval 0 to 1, because what? Because VP of T is less than 0. Does that check out, guys? Does that make sense? Does anybody have any questions there? I think there's some stuff in chat.
Can we use the inequalities for solving instead of like if I like put the inequality sign?
Oh yeah, that'd be fine. And also this should be a squared bracket, sorry. Reason for that is that they used or equal to signs on this. So we kind of match with whatever they do. And yeah, if you wanted to do inequality symbols, there'd be nothing wrong with saying 0 less than or equal to X less than 1.
Yeah, how about the first part? When we set the fraction like equal to 0, can we put it like smaller than 0 in that part?
No, you don't want to pick a number. You mean in terms of like plugging a number in?
No, the upper part, the fraction part. You set it equal to 0. I like set it like lower to 0, like set it smaller to 0.
No, because we're not looking for where it's smaller than 0. Right now, we were looking for where it is 0, because that's how I find my critical point.
Okay, got it.
And then after you locate that critical point, then we pick something smaller and bigger than it.
Okay.
I have a quick question. So if you had been able to, I don't know, let's say like factor the bottom, would you also add those into the first derivative test?
Say that one more time.
I don't know if that makes sense, like, because I know for the top we got that like at 1 it equals 0, but if we had something
Something on the bottom that would have given us 0.
Yeah.
Okay, so here's the story when that happens. There's 2 scenarios. If you have access to the original equation, which we do, so let's just go pretend. 3 makes this 0. Okay, in our pretend world, 3 makes this 0. So you go up to the original equation and you plug in 3. If it gives you any normal coherent number, including 0, cool, you can use it. If this were a fraction and it would blow up the fraction, meaning it would make the bottom 0, then you can't use it.
Okay.
Does that make sense?
I think.
And if you don't have access to the original function, we don't know what it is, then you use it. That's usually the rule of thumb for all those problems. That's a very, very rare situation though. Usually you don't get too involved with that.
So like, let's say you just had like this, basically like the velocity, would you like, and if it was 3, would you do 1 and 3 and then test the numbers in between, like 1 and 3 as well?
Yeah, exactly. So like if 1 and 3 worked, then you would use them all just like normal.
Okay, got it. Okay, sounds good. Thank you.
Yeah, it's just, you just take a peek back at the original to make sure that it doesn't blow it up. And if it doesn't, then you keep on going like normal.
Okay, sounds good. Thank you.
Mhm. All right, part B. We want to find all the times where the two particles travel in the same direction. Okay, now, good news, we've already done half the problem. We already did part A. What do we know about particle P? So I'm going to put a P beside this and underline it. I already know about particle P. It's going to the left from 0 to 1. It's going to the right from 1 to, that's 8 where this problem ends, right? So this problem from 0 to 8, I've already mapped out particle P. We just now want to do the same exact thing for particle Q and then compare the two and see where the overlaps are at. And that would be the times or time, depending what the answer is, I don't know, where the two particles travel the same direction. So now we're doing all things for particle Q. So let's go find the velocity for Q. It's up there. They gave it to us. That would be t squared minus 8t plus 15 is 0. This one is factorable. That's t minus 5, t minus 3. We're going to have 3 and 5 for our critical numbers. We're going to have 3 and 5. And now we need to go and test these out. So let's go with 1, 4, 7, something like that. So just remember, we're doing this with particle Q. So I want to go back up and use the formula for velocity for particle Q, which is the t squared one. All right, so if we plug 7 into that, 7 squared is 49, 49 minus 56. But plus 15, 7 is going to be a plus. All right, how about 4? That would be 16. We got to do the math here because he's come out close. 16 minus 32 is a negative 16 plus 15. No, that's not going to do it. That's a negative. And how about for 1? If we put 1 in there, that's going to be 1 minus 8 plus 15. That one's going to give us a plus. All right, now we need to compare these two charts and see where's the overlap. So I'm going to draw a number line for each of these. You can do it however you want, but whenever I'm doing overlaps, I like to do number lines. So if my first one is like this, and that's going to be 0, 8. So it's pretty easy to see what's going on here if you make these two number lines. And then the other one from 0 to 3, sorry, from 0 to 3, 3 to 5, 5 to 8. What do we have? This is going to be right, left, right. Okay, now we just compare these two and see where do they match up. So let me turn the screen share off so you can see a little better. All right, we're looking for where they match up. So this is 0 to 1, nothing happening. So it starts going to the right for P at 1. So I'm just going to draw a little connection down here. And then that's good to go. We're matching right now because we're still going, this is still to the right. We're good to go, but then that's going to cut off at 3. So from 1 to 3, we've lined up. All right, now we keep going. Nope, 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 nope. And then once Q gets to 5, it goes to the right. So does P. So in terms of this, we've got matching directions from 1 to 3 and 5 to 8. Does that make sense? So how would we rate this out? I don't have to rate all this. The particles are traveling the same direction from, I tend to just do the parentheses. I would say from 1 to 3 and 5 to 8 y, because both the velocity of p and the velocity of q are what, if we're going to the right, that's greater than 0, right? Are greater than 0 on these intervals, something like that. So hopefully that makes sense as you start to see these, because that, all those ideas you're familiar with, now you're just doing them a little bit by hand. Do we have any questions on part B? Okay, back to our screen share, and we are headed to part C. Find the acceleration of Q at t equals 2. Okay, so we've already got some of this. Find the acceleration of Q at t equals 2. Easy enough. Is the speed increasing or decreasing at this time? So what's the plan? Someone walk me through it. After I find the acceleration, what do we need to tell if something is speeding up or slowing down?
We plug in the number and multiply to figure out whether the answer is negative or positive.
Plug in where? What am I plugging into?
To the velocity and acceleration both.
Yeah, exactly. So for part C, first thing I would do is show the acceleration formula, because it very clearly asks you to find that. So AQ of t is equal to 2t minus 8. And then AQ of 2 is equal to -4. Okay. So the next thing we need is the velocity at 2. So what is that going to be? If we plug that in, it's going to be what? 4 minus 32 was what? -28. What'd you say?
Yeah, I got 3 for that.
For plugging in 2?
Yeah.
No, I'm sorry. Hold on. I'm looking at the wrong formula. So that would be, I'm going across that here. I have to make formulas. 2 would be 4 minus 16 is -12 plus. Yeah, I agree. So +3?
Yeah.
Yeah, that checks out. All right. So now we know the deal. We know how to do this. You could just make your next statement here that says what? Is it speeding up or slowing down?
Slowing down.
Slowing down at t equals 2 because AQ at 2 is less than 0 and VQ at 2 is greater than 0, and you have got full credit. So do I think all of these problems so far are absolutely doable? Yes, but even if A and B went off the rails, I will keep reiterating my theory of don't give up, because part C, everybody should be able to get that 100%. So worst case, always look for the points you can get. Okay. Any questions on C? Okay, it takes us to our final part, part D. Find the position of the particle Q the first time it changes directions. So, some good news to be had here. You already know that answer. What is the first time that it changes directions? Particle Q.
1.
Look closer. Particle Q, not particle P. Yeah, so it's at 3, right? How do we figure out when it changes directions? You do your first derivative test, right? Or if you're doing it graphically, which is what a lot of these problems were, what was the plan? You graph the velocity and see where it crosses over. In other words, where does it change from one symbol to the next, right? So algebraically, that's a first derivative test that we just did. And you want to see, well, what's the first time it changes signs? That's going to be at 3. if you were to graph this velocity, the first time that it crossed the axis would be at 3. So we can translate this question again. Find the position of particle Q at t equals 3. How do we find position? We integrate. What do we integrate? We integrate the velocity. So the velocity for this whole problem is about Q is t squared minus 8t plus 15. Make sure you put your d whatevers in. They can sometimes take points off from that. Okay, it's going to be from a bound we want and a bound we know. What bound did they give me? T equals 0 is the bound they gave me. And the one we want is 3. All right, so we are going to integrate this and see what we get. So this is your velocity formula. Now, this is the same thing as saying via t dt is equal to, make sure we understand this is the same thing. It's the same thing as saying x of 3 minus x of 0. Those are identical, right? So all you're doing is integrating this and plugging in these pieces. Which one are we looking for, though? We're looking for which piece?
V of 3.
All right, so we want x of 3, right?
Yeah.
Okay, so let's keep it the way we're used to seeing it. So we're going to integrate via t, vq at t, sorry, from 0 to 3, and that's going to be equal to x of 3 minus 5. Okay, we want to solve for this. So you need to go somewhere and integrate vq of 3, which is the part I just wrote up here, from 0 to 3. Okay, if we go and integrate that, what's that going to do? So here's our scratch paper. We want to integrate this. That would be t to the third over 3 minus 4t squared plus 15t from 0 to 3. Okay, we need to figure out what that is. So it's going to be plug in 3 minus plug in 0. If we plug in 3, that's going to be 27 over 3, which is 9. 9, what's that? Another 9, 4 minus 36 plus 45 minus plug in 0 is 0. So what does that give us? 9 minus 36 is what? Negative 27. And negative 27 plus 45 gives us positive 18. So that piece is 18. So 18 is equal to x of 3 minus 5. So add that over, and that would be the position. You should all have Q's in it because that's the way the formula is written. Is I'm coming up with 23. Did anybody get the same thing?
Isn't 3Q 27?
Did I make a mental math mistake?
I think so. Though I could have also.
Let's see, 3 cubes 27. Yeah, but it was divided by 3.
Oh, got it.
Yeah, I believe that's right. Even more importantly, yeah, so let me look it up real quick on the answer key here, see if it checks out, because I have an answer key saved. Yeah, answer is 23. But more importantly, beside that fact, the idea, the big idea here is the problem makes sense. So does the setup make sense? Does working through it in the little chunks we did there make sense? Do you have any questions on the setup or anything really?
When you got 18 equals xq of 3, why do we subtract 5 after that?
Add 5.
Okay, thank you.
Anything out there? Okay, hopefully.